Pelainen. I'm the Prince Sultan bin Abdulaziz Professor of Energy Resources and Environment here at Johns Hopkins SAIS, and I'm also the Director of our Initiative for Sustainable Energy Policy. And today I'm very happy to introduce Ben Zaitchik, who is an Associate Professor in the Department of Earth and Planetary Sciences at Johns Hopkins University, so up the street in Baltimore. He's done lots of very interesting work on regional climate variability, water resource monitoring, disease early warning, and climate change adaptation, really all over the world, with active projects in East Africa, the Middle East, and Latin America. He has a PhD in Geology and Geophysics from Yale University, and prior to joining Johns Hopkins, he was a research associate with NASA and a foreign affairs officer in the U.S. Department of State. So he has extensive experience both on the scientific side of things and the policy side. And so what we'll do today is Ben's going to talk for about 40 to 45 minutes, and after that I'll just open it for questions and comments. Hopefully we can have a good discussion, and we'll hope to finish by 2 p.m. today. So Ben, please take it away.
Great, thank you. Thank you, Jonas, and thank you, everyone, for coming. And so we'll do questions after, but also where I come from, interruption is expected. So please jump in with any questions as we go along. The topic today is, as the title indicates, water, food, and energy as independent quantities and their interaction across the eastern Nile Basin. And I've opened up with a picture here of a homestead that we're working with in the Ethiopian highlands of the eastern Nile Basin. And I'm opening with this intentionally because when you think about food, energy, and water and development dynamics at the homestead scale, the fact that you're in the eastern Nile Basin feels it's really an abstraction, right? Food here is produced on farm or it's acquired through local markets. Energy is almost entirely biomass. Everyone's off grid, okay? And so you're basically talking about wood and other fuels. And the water, yes, you know, this trickle is on its way to the Nile. So it's related to the Nile, but again, it's a very local problem, and it feels very remote from the kind of global geopolitics that often come to mind when one thinks of the Nile. At the same time, scaled across the landscape, activities here are entirely relevant to the eastern Nile Basin. Certainly the source of energy, for example, which has led to massive deforestation, and now more recently a growth in plantation forestry that has a lot of evaporation associated with it, that influences the Nile water balance. Erosion rates, famously here, are about the highest on Earth, and that's what has led to millennia of fertile agricultural production in Egypt, and now in more modern times, it's led to interactions having to do with sediment and dam efficiency in Sudan and in Egypt, as well as the fact that you're talking about the population here, right? And so any development initiative that goes on across the eastern Nile Basin or at national scale will influence what happens here with people's livelihoods and the landscape. And so those interactions across scale are something that we're trying to get at. And it brings me to my alternate intro slide, which is what most people would probably view as the way to start a talk about the Eastern Nile these days. And this is a construction site of the Grand Ethiopian Renaissance Dam, which, well, who's heard of the Grand Ethiopian Renaissance Dam? So I know the audience here a little bit. Some, no, okay, most people. All right, it even makes the US newspapers, right? That's just what a big deal this is. That doesn't happen very often. But this is I'll talk more about it later, largest hydropower project in Africa. And it's right on the main stem of the Blue Nile, okay? And so this is very much at the center of geopolitics. This is something that people talk a lot about, how energy generated from this dam, how its impacts on irrigation for agriculture, including food production, might play out across countries, okay? So how do these two interact? And what I want to try to explore today is this question of how water, energy, and food operate interacting across scale. So this is basically the outline of the talk. Think of this as the basin scale across countries, this as more of an administrative scale, and then down here at local all the way to the farm scale. In each place you've got a different nexus of food, water, and energy operating, and they might interact. And so I want to explore the question of, is this a useful way to think about things? And I should say going into this that I'm not 100% convinced it is. It is sometimes, I think, in some contexts. But the takeaway questions, which is the same place I'm going to end up at the end without any answers, but things that I'd like to encourage us all to think about, are, is this idea of a food, energy, water nexus useful? in the Eastern Nile Basin and perhaps more broadly in these kinds of resource problems? And if so, to whom is it useful? What are the decision makers, or who are the individuals that might ultimately benefit or be informed by bringing these resources together in our analysis? Okay. So first of all, let me explain the title for those who don't think about these kinds of obscure things all the time like I do. So water, food, and energy. This idea that there's a nexus among them, so an interaction, not just that they are all in parallel stresses, but that there are interactions that could be constructively explored, has really become a kind of a catchphrase, to put it in a flippant way, but I think also perhaps a lens for viewing resource development over the past decade or so. And here's one example, which is the U.S. National Intelligence Council, right, the long-range thinkers of our intelligence community, who identified the increasing nexus of food, water, and energy as one of the most critical issues happening in the world over the next 20, 30 years, or 15 to 20 years. And when they said this, right, part of it's just because of trends, okay? We know that there is people talk about this all the time, the increasing demands for food, particularly high energy input foods like meats across the world. Energy, right, the electrification of the globe that's going on right now, and the associated use of water for both of these. In parallel, these are all increasing, but also the interactions are evolving. And so that's the idea. That's where kind of the idea of this nexus was born, that we need to be thinking about these resources in concert. So in the second half of the title is the Eastern Nile Basin. And so in case it's not obvious why I'm specifying the Eastern Nile Basin, it's for the following reason. So this is a figure courtesy of Ptolemy, and that's that we've known for a long time where the Nile comes from, right? It's been a long time. This is from his map of the world. He lived in Alexandria. And the pointer's not working so hot. But what you have is the main stem Nile flows south to north. Oh, that's even worse. All right. It flows south to north. And so you have two headwaters regions, okay? And this was known for a long time, that there was a confluence, which is around Khartoum, between rivers that come in from the east, the Eastern Nile Basin, headwaters in Ethiopia, in modern-day Ethiopia, and the Equatorial Lakes region, okay? And that's the White Nile. The White Nile is coming out of the Equatorial Lakes. To take a little more modern view of that, here's an outline of the entire basin. And again, you've got the White Nile that comes from here, from Lake Victoria in the Equatorial region, and then the Blue Nile and the other Eastern Nile Basin rivers coming out of the Ethiopian highlands. Okay, so a few points about this. Why is it so important to distinguish between the two? So I'll take this from a hydroclimate perspective, because that's what I do, okay? You can see this is just evaporation I'm showing here. Don't worry about it. It's basically, the Nile is one of the great allochthonous rivers on Earth, in that it takes its water source from very humid highland regions in both headwaters, and then it winds its way through some of the driest deserts on Earth to the sea. The White Nile, which comes out of the Equatorial Lakes, is a highly hydrologically buffered system. Okay, so what I mean by that is that it rains. They get 2 rainy seasons a year. You get a lot of local evaporation. You have a series of lakes, Victoria, Albert, Kyoka, and some others. And then you've got this thing, the Sud wetlands, which I won't talk about too much today, but it's a place that's highly evaporative, okay? So you get 30 billion cubic meters per year flowing in the White Nile into the Sud, and you only get 15 out, all right? And all of this means that you have a hugely buffered system, so that although it rains a lot in here, and there's a lot of rain variability that matters locally, it's been estimated that if you extract 1 billion cubic meters of water per year around the equatorial lakes, you'd only get 0.1 billion cubic meter impact when you get downstream of the Sud. Okay, so only like 10% impact because it's so highly buffered. Meanwhile, the Eastern Nile Basin, so the Blue Nile is the big one here, and then we have the Sobat to the south and the Atbara to the north, and these are rivers that are coming out of the highlands, and they just tear out of the highlands, okay? High hydrological connectivity, in that they make it very quickly down into Sudan and then Egypt. When Khartoum floods, it's because of the water coming out of the Eastern Nile Basin, okay? So this connectivity, I mean, again, it's been known for a long time. So the White Nile and the Blue Nile, why are they called that, right? The White Nile is because it's counterintuitive to the way we think about water. But White Nile was because it was clear. And Blue Nile, right, blue is kind of a mistranslation of black because it was so laden with sediment, okay? Because you get heavy rains in the Ethiopian highlands, they tear down with all the sediment with them, and it's just a very silty river, okay? And that's what brought the silt to Egypt. So what that means in sum, I'm not going to get too much into the hydrology here, but that if you look at if you look at this as just a hydrograph, okay, so if you're not used to looking at these things, months of the year on the x-axis, and the y-axis is the flow per day. And down at the bottom, you see the White Nile, which gives this low, steady flow that's only going to be about like 10% of the total flow that gets to Aswan, Aswan Dam being right here at Lake Nasser in Egypt. And instead, about 85% come out of these eastern Nile rivers, dominated by the Blue Nile, which contributes over 60% of the flow to Aswan, contributing also from the Atbara and the Sobat, which is not shown here, that's another percentage. So it's 85% are coming in, and it comes in flashy. It comes in a big storm peak or flow peak that hits you in September, October, and it varies a lot year to year because it's not a buffered system. And so that connectivity explains why I think it helps to explain a lot of what's going on with the controversy these days. So first of all, it means that I'm going to talk about the Eastern Nile, which really formally I should just be talking about these three watersheds here, the Sobat, the Blue Nile, and the Atbara. But we're also going to include in that the main stem Nile north of Khartoum, because that's where, if 85% of the flow in that main stem Nile is coming from the Eastern Nile Basin, the connectivity is such that we're going to talk about that in the Eastern Nile context. And now people have been looking at this for a long time, right? So you can go to visit the Nilometer outside of Cairo. It's been operating for millennia. Well, it doesn't operate right now because the river shifted, but for millennia it did operate, checking the levels of the river, and it was the subject of monitoring and prognostication for a long time. And when Egyptians were monitoring the river here, what they were really doing was seeing what was happening in Ethiopia, okay? Because 85% of the water is coming from Ethiopia. That's what's driving this signal. And so there's been this interest between upstream and downstream connectivity since the beginning. Now that has led in the modern era to a number of treaties and agreements, okay? All trying to get at this problem of the Nile in general, but really the Eastern Nile Basin because of this connectivity issue. And so don't read this, but what this is just a beginning of a list of all the treaties that have gone on, okay? And just cut to the chase, there's no comprehensive water sharing agreement today, all right? So there's been a lot of paper, and a lot of people spend a lot of lawyers spend a lot of time thinking about this stuff in interesting ways, but it hasn't actually led to an agreement. I'm just gonna highlight three right now. First one is the 1902 agreement. I'm saying that only because I'm at SAIS, and I know there might be some real scholars here who think about the meanings of colonial era treaties, okay? I've heard from such scholars that this one matters because Ethiopia, famously never having been colonized, only occupied briefly by Italy, is still the same nation now as it was in 1902, albeit through several changes of government, such that if they sign this treaty, even though they signed it with the British, maybe it should still be viewed as binding by that country. I think it doesn't matter because I challenge you to find an Ethiopian who views this treaty as binding, but in a legal sense, it might be. Now, this one matters more, the 1959 agreement. People talk about the 1929 also, but we can talk about that in questions if you're interested. This one matters a lot because it's the utilization of the Nile Waters Treaty, okay? And a few points here. It was negotiated only between Egypt and Sudan, both independent by that point, with no discussion from the other now 9 countries on the Nile. And they said, okay, between the two of us, we can agree to share all the water of the Nile between us. And there's a natural flow of 84 billion cubic meters per year. So Egypt says, we'll take 55.5. Sudan, you get 18.5. And then there's an extra 10 that we know is going to evaporate from that reservoir at Aswan that we're going to have. All right? And so the full 84 are accounted for. Clearly, this treaty is not recognized by any of the other countries, right? Because they weren't invited and they didn't agree to the fact that they get no water. Nevertheless, it is viewed as legally binding by Egypt and Sudan and defines a negotiation position today. Okay, so it's relevant for that reason. Finally, right now, the Nile Basin Initiative, which is a consortium of the 11 countries, has been, for the past decade and a half, has been limping towards a cooperative framework agreement, trying to establish principles by which all the countries will be involved in this discussion. And Sudan and Egypt have walked out multiple times. Other countries started signing it without them because they only needed 7 to ratify it for it to become effective. So they don't need Egypt and Sudan there to start to make this take effect. And it's really close now in that 7 have signed, but 7 have not ratified. Last I checked, only 4 have ratified. So it's not yet in effect. It will not include an allocation. Like there's no math in this agreement. But what there is agreement on principles. Okay, and So on this backdrop, okay, so the Nile Basin Initiative kind of came out of negotiations in the late 90s. In the early 2000s, they started negotiating this cooperative framework. It was give and take, push and pull. All of this was going on. And then in 2010, let's just say 2010, I think plenty of people knew about beforehand, there were rumors of this Project X happening in Ethiopia. All right. So what was Project X? So Project X was this idea that Ethiopia was building a big dam right on the Nile. Okay, and right now there are no dams on the main stem Blue Nile in Ethiopia. Okay, and so this, of course, flew in the face of Egypt's historical hegemonic control of the Nile. It also was a threat, they thought, to the 1959 agreement, in that it suggested Ethiopia might start pulling water out. They also insisted it was a violation of the 1902 agreement, which Ethiopia, still Ethiopia today, had said we won't interfere without talking to you. Okay, and so, and then you get to the saber rattling, and this is I think that this is not constructive, all right, but nevertheless, it has framed kind of popular understanding of the debate, all right, which is that these are both quotes from 2010, where when this Project X discussion started happening, Egypt and Sudan said they might go to war, and then an Egyptian parliamentarian, you can always get a good quote out of an Egyptian parliamentarian, right? I mean, and so, in one of many times they were threatening war on Ethiopia, and this was just as this dam was being discussed. And then, regardless of what you think of the late Meles Zenawi, this was a great retort. And so the Prime Minister of Ethiopia basically said, bring it on, right? We got this. So this was not a healthy contribution to the ongoing discussion of the cooperative framework, right? And indeed, it explains why it's been so stalled. And so then in 2011, Project X was made public, okay? Later renamed the Grand Ethiopian Renaissance Dam. So in more, cloak and dagger stuff, I mean, people do point out that Meles announced this in the week that Mubarak fell from power. Okay, and so the idea was Mubarak and former leaders of Egypt had always sworn they would bomb any dam that Ethiopia built on the Nile. So you wait for the one moment when they're not in a position to do it, you unveil it, and by the way, it's clear that you've been planning the construction site for at least a year or two. Okay, so you've been doing it. I don't really buy the full cloak and dagger story on that, because this dam site was identified by the United States Bureau of Reclamation in the 1950s. Rumors have been swirling for years that they're going to build there. Again, asking an Ethiopian, Egypt has spies all over, okay? The US has intelligence and cares a little bit about this region. Like, we didn't know that they were building a dam there. Like, I feel like people knew, all right? But nevertheless, it was unveiled, and everyone, was shocked to hear there was dam building going on here. And it launched it, and then this, kind of, as one might expect, there was reaction in Egypt, there was reaction around the globe. A lot of negative reaction towards Ethiopia on this at the time, from the West, because Western powers were very much invested in this cooperative framework, and that we're going to talk this through. I don't think anyone objected to the idea that Ethiopia would eventually build a dam, but they didn't love Meles unveiling the largest dam in the history of Africa unilaterally while we were supposed to be in a negotiation. Nevertheless, it's the largest dam in the history of Africa, and it's happening. Okay, it's almost done now. A few stats, if I can remember them. So installed power capacity, for people who think in these terms, of over 6,000 megawatts, okay? What does that mean? Ethiopia's current, or as of 2014, Ethiopia's installed power capacity as a country, 2,400 megawatts, okay? So this triples or more their power. When you actually talk about how much can you generate, because that's a question, is this oversized? Just because you install turbines doesn't mean they turn. Nevertheless, now let's see if I can remember the number. I believe that this will generate, they think on the order of, I'm going to say 3 times what Ethiopia generates right now, okay? So the installed capacity will triple, and the generation will also triple, okay? Ethiopia doesn't know what to do with this power yet, right? And so that's why there's a lot of discussion about how a lot of it will probably be sold elsewhere in the region, and there are agreements underway to sell it to Sudan, to sell it, and then Sudan, because Ethiopia won't talk to Eritrea, Sudan will then turn around and sell it to Eritrea, and so there's a whole bunch of energy sector integration going on here. It's going to be economically efficient. It will generate at a price that's about half of what it costs Sudan to generate their own power. So that's useful. It will also, as Ethiopia will point out, be much less evaporative than Lake Nasser, because it's not located in the middle of a desert. It's also deeper, and so there's less evaporation per head on your hydropower generation. Okay. So that's the GERD, okay, the Grand Ethiopian Renaissance Dam. And now what this does is suddenly it takes, all of the treaties are about water, and now we're saying, well, no, let's talk about what this is really about, this water and energy equaling money, right? And that this is the engine that will fuel Ethiopia's development, both through internal generation of power and probably, at least for the first decade or so, hard cash sales to other countries. Now, there's a really, the first argument that one could make to downstream countries, well, Egypt in particular, we'll get to Sudan in a second, is that, hey, you should be happy about this, right? Because if Ethiopia wants to tie their future to generating hydropower on the Blue Nile, what does that mean they have to do? They have to run water through the turbines, right? And any drop they take out upstream is money out of their own pocket. And so, in a sense, in the long term, and that's true, right? And so in the long term, there are some problems for Egypt in terms of what this means about maybe the sustained head on the generating facility at Aswan, because Aswan will probably run lower. So there's a hit there. And there's a problem with the salt balance, of the Nile. They have salinity problems, and you'll have a little more evaporation. So there are these issues, but those are not existential issues, right? Those are like on the margins. Does this help or hurt us? Let's negotiate. Try to get maybe some payback for any hit we take. But it's not like Ethiopia's turning off the Nile. Reservoir filling, a big deal, right? So the reservoir capacity is 74 million cubic meters. 74 million cubic meters. Annual flow of the Blue Nile is 48 million cubic meters. So it's a year and a half of flow that they got to use to fill this thing up. So that's a big deal, negotiating the reservoir filling. But once it fills and you're in a steady state, in theory, that's not a problem for Egypt, or at least not an existential problem. And so what we did, we said, okay, well, let's bring food, or at least agriculture, okay? It might not, you don't have to produce food on your fields, but irrigation, perhaps, or food production into the picture, and how does that play? And we said, well, we aren't going to look at Ethiopia, because Ethiopia is going to turn the turbines. Also, Ethiopia doesn't have a lot of irrigable land in the highland areas that feed into this dam, okay? There's not a lot of potential to pull water out. Sudan, however, especially this part of Sudan, has the geography of an infinite fertile plain that lacks only for water, okay? And now, what we decided to do was look at, here's the current infrastructure. So that's the Grand Renaissance Dam, the G there, that's about to go active. And then we have R is Rosaires and S is Sennar. Those are the two dams that have been in Sudan for a long time, all right, for mixed-use hydropower and irrigation, feeding large irrigation schemes called the Jazeera scheme that's located there along the Blue Nile. I'm also putting on here, on the main stem, Merowe. Okay, Merowe is a big hydropower facility that went online almost 10 years ago now, down in the cataracts in the severe desert, right, of northern Sudan. It's just hydropower. This puts Sudan in an interesting position because if there's one thing you want your hydropower upstream of your irrigation, and they've got their hydropower downstream of their irrigation, right? So that every drop they take out of irrigation costs them on hydropower. It's not their fault, it was the geography, okay? But it causes an interesting set of trade-offs for them. There's Aswan, just for context. So G, Grand Renaissance Dam goes up. What's that going to do to Sudan's water use? And so we built, my student Saleh Sateh built an optimization model. Just these arrows, for those of you who think in optimization model speak, it's just doing the flows, right? You got river flows coming in from the Blue Nile, the White Nile. You've got dams that are evaporating from the reservoir, that are feeding irrigation that evaporates even more, and that are sending reservoir releases downstream that could generate hydropower. Okay. And so here's where things we thought got interesting. The Sudanese agricultural sector is not a well-oiled machine, okay? Right now it is not very efficient. So we say, okay, what if you're operating just a moderate agricultural profit? Okay, so your agricultural sector isn't killing it, all right? Which is the reality today. You can throw some numbers on that. And we say, well, what are you going to do for irrigation and hydropower if the following things change? What if it gets rainier? What if it gets drier? What if there's an upstream dam, like the GERD? And also, what if there's an upstream dam and you've got an agreement with Ethiopia to buy the hydropower from them, okay? At some price that, again, can be drawn from negotiations that are now public about how much Sudan would pay for this. And again, it costs you half as much to generate at the GERD as it does at existing Sudanese facilities. Okay, so what happens? If it gets rainier, everybody's happy, right? There's more water to go around. Sudan might irrigate a little bit more, but they're definitely going to do a lot more hydropower. okay, because they'll be able to turn the turbines more, and that's actually more profitable for them as long as their ag sector is not that productive. If it gets dry, here's where we were a little surprised by this. Irrigation, not surprisingly, goes down. Hydropower actually goes up a little bit, and this has to do with the timing of when the rains come and current storage capacity that you actually they still end up allocating more to hydropower simply because there wasn't enough water for the crops, so they used it for hydropower, just a small increase. You put an upstream dam on this, and also interesting, what the upstream dam does for Sudan, first of all, it gives them control, all right? The Blue Nile is flashy and variable, and they don't have control over it right now. The storage at Rosaris and Sennar are not sufficient to store it, to use it optimally. They have to let a lot of water go. The GERD basically gives them this nice constant stream of water coming through that they can do anything they want to with. Secondly, it's a nice clean stream of water because all the sediment fell out in the reservoir of the GERD, and so suddenly you aren't getting your irrigation works gummed up by siltation every year, okay? So anyway, they use that control to generate more hydropower, because now they don't just generate hydropower in the wet season, they can generate all year long as you get this nice steady flow. But what happens if Ethiopia builds a dam and they agree to sell you electricity at a reasonable rate? Well, then you say, well, okay, I'll irrigate, because it's better for me to buy power and then use that water to create crops. Okay, it changes your trade-off. Now what if you modernize your agricultural sector? Rain and drought, small changes there, but what I want to focus on here is what happens with the upstream dam, particularly with a power agreement. Suddenly, if you've got a profitable agricultural sector and you've got Ethiopia controlling flow for you upstream with no sediment coming through, it becomes very attractive to irrigate. Okay, very attractive for Sudan to irrigate. And so this is just economic optimization, all right? We did nothing to change any of the other, kind of policy or objectives. It's just how many dollars are you creating. And in these three scenarios, you irrigate more, and the 1959 treaty comes back. Right now, Sudan uses less than its allocation. It probably uses 12 or 13 billion cubic meters per year because they don't have a modern agricultural sector. If they did this, if they invested in agriculture, if they had control and they were buying power cheap, they run up against that 18.5 billion really quickly. They start double cropping, triple cropping, expanding. That's already happened on the Tekeze River, the Atbara Tekeze, which is that river that's just north of the Blue Nile where Ethiopia already has a dam. Sudan's gone from single crop to triple crop, okay? And so this makes things a little bit interesting because you have, of course, this historical association between Sudan and Egypt negotiating together that carries on today. You have the fact that both countries recognize this treaty, right? But you have another fact here, which is that with an upstream dam and power sharing agreement, it becomes a huge economic constraint in Sudan. It ends up costing them a lot to recognize this treaty. So in thinking about the GERD and whether it's an existential threat to Egypt, the GERD is not an existential threat as long as you get through the reservoir filling if you're just thinking about Ethiopia-Egypt dynamics. It might be a small cost, but it's not the biggest problem you've got. But if Sudan decides to start using the water, as they will have the physical and ability to do and the economic incentive to do, that becomes an existential threat. Okay? That becomes something that can actually take a lot of water out of Egypt. And the good news is these countries are friendly with each other, and maybe it won't happen, but it's going to be interesting to see how that evolves. Okay, so now that's the large-scale picture. Okay, water, energy, and food interacting at the basin scale with respect to the Grand Renaissance Dam. There's a lot more that could be said about that, but enough already. The idea here is that these sectors do matter to each other, and that when you think about this just as a water problem, it's a zero-sum game where everyone's fighting for a drop in the abstract. When you add energy to it, suddenly there's this idea of integrated energy grid that there are going to be winners. Sudan wins based on water energy alone because of the availability of cheaper power in the region. Okay? Then you introduce this idea of food, or at least agriculture in the form of irrigation, and suddenly the dynamics become a little bit more complex, and it's something that you might want to think ahead on. For political reasons right now, Egypt and Ethiopia are historic enemies, so they like to go at it with each other, and Sudan just kind of sits there quietly. All right? Meanwhile, Sudan is in active discussions with Ethiopia and clearly has been since before this project was announced. All right? It's located like 10 kilometers from the border, and they're going to be selling power to Khartoum. So Sudan is benefiting, but at the same time is aligned with Egypt in all negotiations. And it's really when you start thinking about what might happen with irrigation that kind of happy quietude starts to break down, right? Like when will this actually come to a head? Okay, we should throw climate on top of this because Why not, right? So how is climate variability and change going to influence this whole dynamic? Those of us, in the U.S. here, we worry about this with the U.S. West, for example. Famously, the Colorado River Treaty was negotiated, or agreement was negotiated at a time of high flows. Under climate change, it's getting drier. What's going to happen? In the Nile, the good news is that the negotiated treaty that Sudan and Egypt have was actually negotiated during a low flow period, so it's not overly constrained. But you might have noticed that in my last slide, I was just looking at high rain and low rain scenarios. Okay, I wasn't putting anything specific on there. It's quantitative. We did 20%, but why did I choose those? And here's why. Here is a typical plot of what happens if you bias correct all your global climate models participating in the IPCC reports and look at their rainfall in the Blue Nile Basin feeding into the GERD over the next 100 years or so, and you end up with a total mess of answers, okay? Because there's huge uncertainty in this region. Now, various researchers, including myself sometimes, have argued that, you can narrow that uncertainty through intelligent model selection, but it's hard, and picking winners in global climate model world is always tough, all right? So no matter how you slice it, there's large uncertainty. If you take the average of all that spaghetti, you get a small increase in rainfall, which might translate to a small increase in inflow to the GERD. It's not necessarily true, right, because you also have more evaporation, but it seems like you might get a small increase of flow to the GERD.
But it's still higher than the average flow when the treaty was.
It's still higher than the average, absolutely. That in the average, okay, with large uncertainty. You've got some global climate models out there that say that rainfall is going to reduce by 40% over the Blue Nile. You've got others that say it'll increase by 80%. The average ends up being, I think, a 6% increase in rainfall, 2% increase in runoff, something like that. So it's not big, but a small increase, which is better than a decrease, right? Better than the Tigris-Euphrates, all right? But the big deal here, so first of all, there's large uncertainty, which will come up back in a moment when I talk about what we're doing with this information. The biggest news here, though, is that there's an increase in variability. Okay, so you have more rain, but it's going to be more variable. So I have to do this. This is my job. So why? Right? Because of El Nino. All right. Most global climate models. So here's your coefficient of variability in Blue Nile flow, the blue line, historical, and then increasing in the future. And plotted alongside is a red line. This is not my work. This is work from a group at MIT. Along the red line is what these models are predicting in terms of the total variability of the El Nino Southern Oscillation. They think it's going to get some more variability, and that is becoming more and more a consistent result of models. In the recent past, people thought we'd go permanent El Nino or La Nina. We might, but more and more of the models and analysis are suggesting we're just going to get bigger and more frequent El Nino and La Nina events. Okay, so that's why it's becoming more variable. Now, the implication of this, and here's the implications for the Blue Nile, is that basically El Nino causes huge droughts in the Blue Nile. So this is from the Famine Early Warning System monitoring system, and you'll see that in 2015, the historically big El Nino we just came out of, that big red blotch over the Blue Nile, you end up with big droughts. And if you average all the El Nino years over the last 35 years, you see that, yes, there's variability, but on average you get drought over the Blue Nile. So you get low flows. Now, the implication that these folks at MIT took out of that was that you might want more storage. All right? Right now, there are 155 billion cubic meters, or 155 cubic kilometers of storage on the Blue Nile, on the Eastern Nile Basin system, if you include Aswan and Merowe on the main stem. Once you get the GERD online, you're up to about 230. Okay? So you have 230 cubic kilometers of storage. In the past climate, which is blue here, that buffers you against most return periods of extreme high and low flows. In the future, which are the red lines, it only buffers you up to about the 30-year return period. In so much as you view it as a priority to have full control over the flows, that you can leverage, that you can always take in a flood or survive a drought without changing your operations, that means that you need more storage to maintain that capability in the future. So I think a takeaway from this, and you know what, you don't even need pointy-headed MIT people to tell you this. Look at the plans in Ethiopia and Sudan for dam building, all right? The GERD is not the end of this, right? There's going to be dams and dams and dams. And so what you need is some approach to discussing storage cooperatively, cooperative management, in a manner that is not just about the GERD, but is about a general approach, right? And that's what the Nile Basin Initiative is working on. That's what the more recent Khartoum agreement between the Eastern Nile riparians is working on. But this is an inevitability, all right? And so it's something that needs to be addressed. Okay, so that's it for the large scale. Moving down to moderate scale, okay? And I'll be briefer here. That's transboundary, geopolitical, treaty world. Let's talk about an area where a country actually has control. And so now we're going to be up in the upper highlands here of the Blue Nile Basin around Lake Tana, okay, the biggest lake in Ethiopia now, not soon, because the GERD reservoir will be bigger. And this is the basin around it. There's a lot of active development going on here in terms of both irrigation and hydropower, including a tunnel that was drilled with World Bank funding, the Tana Bellis project that has both irrigation, and what they do is they divert water from Lake Tana through this tunnel to the Bellis River and generate hydropower on the way through the tunnel, okay? There's also hydropower here at the outlet of Lake Tana into the Blue Nile. Okay, so all this is going on. Some of it's active, much more of it is planned. And so we've been working with the Abai Basin Authority, the Blue Nile Basin Authority, and with some other partners on an analysis of what all these plans are going to do in the future to water, food, and energy, and other impacts. Recognizing that we have the listed uncertainties here, climate, land degradation, and the fact that data is limited, so we don't know everything, and other impacts on things like fishing, navigation, tourism, environmental flows, other things that they want to get out of Lake Tana. And so the question here is, if all this development's happening, assuming it all goes apace and you get your new dams for your hydropower and your irrigation, under what scenarios do things start to fail? All right? And we're specifically asking this question about potential failure rather than trying to do some probabilistic analysis or an optimization because of that climate uncertainty. So here's how we did it. Okay, and this was Julie Shortridge's work. She was a PhD student who's now a professor at Virginia Tech. And what she did for her dissertation was she said, okay, I'm going to do a robust decision-making framework approach, okay? So robust decision-making basically is an approach in which you don't try to optimize, you don't even try to probabilize. You simply say, I've got a range of possibilities. Let me explore what they look like, okay? How might temperature change? How might precipitation change? How much rainfall intensity changes, et cetera, et cetera. Then you simulate, kind of basically Monte Carlo style, what might happen in all these future scenarios. You run it through a water evaluation and planning tool that's been developed for Lake Tana, and you say, okay, how is my performance in terms of the reliability and total delivery for irrigation, hydropower, and the other interests I have. The Tissasat Falls flows are a proxy for tourism because tourists like to go see the famous waterfall at the head of the Blue Nile, and when they turn it off for hydropower, tourists get disappointed. Okay. All right. So here are some numbers, but let me explain what's going on here. The acceptable performance threshold, this is what has been defined by the Lake Tana authorities as what they want to get out of these development plans. And so they want 964 million cubic meters for irrigation water, about 27,000 for hydropower in million cubic meters, and they want reliability of like 90% for various things. They want a 30% reliability for the flows, because tourists can be told what time of day to go, right? You don't need those on all the time. And environmental flows as well. Okay, so they've got a good set of criteria. We run our simulations for baseline current climate and land use conditions, and guess what? You always hit your targets because you've designed for the current situation. And so, right, you designed it for this, and it looks like it works. Great. And so the system looks like it's robustly designed. But then you run 1,000 future scenarios, given uncertainty, and say, how often do I fail? Okay? And so this is the inverse of that. This is how many times do I meet what I want? And the reason you meet your environmental flows a lot is because that's given first priority. But then if you look at how am I hitting my irrigation water targets, only in 367 out of 1,000 scenarios, okay? And so on. And so what we see is that as soon as you introduce the uncertainty of the future, there are going to be scenarios under which all of this infrastructure does not do what you wanted it to. And so how might that inform your approach to your development of your energy resources, your irrigation resources? And you can also then play games like this, like saying, okay, well, what do these failures look like? And so you say, okay, my irrigation water reliability, right? Am I delivering water when I need it? Well, one possible scenario where you fail is that if precipitation increases by 3% or decreases, like up to an increase of 3%, so less than 3% increase, and temperature rises more than 1.5 degrees, and this is an estimate of lake evaporation. If all those three things happen, then I start to fail to hit my target. Or if my sedimentation rate gets really high, if it gets up to 1,500 tons per square kilometer due to land degradation, then that alone is enough to make me start failing to meet this target. Similarly for hydropower, if you have simply underestimated the lake evaporation, that's what ETC is, if you've underestimated that at all, then you're going to fail to meet this target in the future. If the rainfall declines by more than 5%, you fail to meet this target. If the sedimentation rate gets really, really high, you fail to meet these targets. And so this allows you to look at the intervention scenarios. And what we've done now is work through things like lining irrigation canals, reforesting the headwaters, all of these different possible interventions you could have to push back against these failures. Okay? And so at that intermediate scale now, we're seeing in the context of climate uncertainty, this idea of water allocation to irrigation and energy, you have to think about these plans in concert, and you also need to think about how you can adjust either one and how those adjustments will impact the other. Okay. So now, finally, let's get small scale. Okay, so what I'm going to do now is zoom in on the Ethiopian highlands, in particular Choke Mountain. Choke Mountain is located right, this river that's going around it is the Blue Nile, okay? And Choke is basically, it's the source of the Nile, okay? And working in collaboration with Balai Samane and others, Balai is a professor at Addis Ababa University, we've zoned this mountain into 6 agroecosystems, which are defined as the intersection of climate type, soil type, and farming practices. And we can view each one as a different adaptation challenge. We then downscale our hydroclimate analysis. I won't get into the methods on this, but we try to get using satellite data in combination with some modeling techniques, high-resolution rainfall, evapotranspiration, soil moisture, and a closer view of what the climate zones are. We can then project forward. Sorry, this isn't displaying so well, but what we have here is rain and temperature, looking at downscaled climate change scenarios going from the present. I'm going to have to point to this. Present, down here. This is where you are in each of the agroecosystems, the dry, hot lowlands up to the wet highlands. And this is what's happening under high emissions or low emissions. All right? It's getting warmer, it's getting wetter, but to different degrees and with different thresholds in each agroecosystem, because now we're really trying to look at this locally. Then you get a PhD student to spend 7 years and counting trying to calibrate a local crop model, okay? And Michael's almost done. And what he's done is in a lot of data collection, a lot of great collaboration from local partners to get the field data for this, to figure out what a local variety of teff does under climate change, right? Which is not currently downloadable, all right? You need to do this. And so we look at each agroecosystem, and here's just some examples of barley, maize, and sorghum and wheat, 4 crops that are grown here. And we see under low emission or moderate emissions and high emissions, RCP 4.5 and 8.5. What is our percent change in yield according to this crop model over the 21st century using, this is the mean of an ensemble of climate simulations. And basically what I want to point out here is that in some places, the highland agroecosystems, like agroecosystem 5, you see increases, okay? That's that top line there, because they're cold limited right now. They're at 4,000 meters. It's a big mountain. Whereas in the lowlands where you're already kind of dry and water limited, you see declining yields, and it differs by crop. If you include CO2 fertilization, then things get a little bit better, but you still get this bifurcation of some crops increasing and some crops decreasing. Okay, so this level of analysis, you really need to zoom into this level of analysis if you're going to talk about food, energy, water interactions under climate change for local smallholder producers, which are the backbone of production in this part of the country. And so we're working with this, again, with Balai's help, or Balai's leadership, with Climate Smart Villages, which are a bunch of platforms that he and his partners have developed in collaboration with local universities and the government to look at what are our climate resilience options, okay? So we've been exploring this and kind of taking these scenarios with them. We're working on them with data collection, but also looking at the different interventions that might be useful to increase resilience to current climate variability as a proxy for future climate. We do not go to these farms and talk about what's happening in the year 2060, right? That makes no sense. We talk about variability and how you can buffer yourself against variability today, which will increase resilience for the future. Okay, so that small scale analysis, really we start off thinking about water and food. This was about food production. But energy started to come into play in a surprising way. First of all, of course, you need energy input for your agricultural production, and it's not mechanized there, so a lot of that's animal traction. And then you get biomass fuels. And one thing that's been very interesting in the past 5 years or so is there's been a massive growth of eucalyptus plantation in this area as people start growing fuel wood instead of growing crops, which is, there are many reasons why this is happening. Partly it's good money. Partly it's because it's a way to show that you are actively that your field is active and you can move to the city for 5 years, but you don't lose your land because it's active in eucalyptus. So a lot of different reasons why this is happening. Eucalyptus, as I think everyone knows, incredibly water hungry, is changing the hydrology of the region, all right? Changing the food production in the region because of the change in land use. And so this has become a local water energy food nexus issue for us. But to try to wrap up with where I started out, is there any interaction between this local water energy food nexus and the large scale? Because everything I've talked about is pretty scale specific to this point. And so we don't know the strength of these interactions. And so that's what we're working on now, and to see is, across basin to administrative to local scale, what's happening, and specifically, how do shocks propagate? How does a local drought that's influencing a farmer here who's plowing for the third time because the rains haven't come yet, how does his food security get impacted, both by the local impact and how does that scale up to national food security, but also how does something like a large shock in the climate system or a large shock in the food system end up influencing farmers in this position? And so we built this model, or set of models that we're working on now, and I'll come back and talk to you more about this in 2 years, hopefully, which is that we're trying to say, taking this from the global scale, everything from climate change and commodity markets, and the regional scale, like these transboundary water agreements, feeding into national scale agriculture and energy development policies in Ethiopia, using a computable general equilibrium model, how that's influencing decisions on grid development and other kinds of investments, which then goes down to the scale of the adaptation zone, which is roughly equivalent to a few administrative units combined, and includes villages, farms, towns, and occasionally a small city. And in there, you've got interventions that we're working on, such as off-grid power, water harvesting, things that we're working on right now with the Climate Smart Villages to understand other farm management approaches. How does all of this interact to influence food security and household welfare as influenced by these cascading shocks from outside? And then how does that all feed back up to maybe influence some of the decisions at scale? So that's where we're heading. Just give you kind of the last substantive slide here. And this is one example. It's messy because this is new, and sorry, we don't have it pretty yet. But what we were able to do is use this model to look at what happens if you have a crop failure, drought-associated crop failure in one adaptation zone in Ethiopia. So we've divided the country to like 17 of these or something. So consider it 10% of the country, all right? That suddenly has a crop failure down to they only get 25% of their expected yield. So what you see here is this is caloric intake for men, women, and children, or just men and women shown here, of high, medium, and low income status relative to their communities. And what you see is their caloric intake over several years. There's a seasonal cycle because there is a bit of a hungry season in this part of the country. But then right here, we've implemented this crop failure. We've imposed a crop failure. So in 1 year, it gets really bad, and people start dropping below nutritional thresholds. And then we say, okay, well, what happens if you intervene with cash aid, direct cash aid? How does that influence access to market food? Because we have food markets in this model. Versus what happens if you say, well, what we need is better transportation to get food into this area. And what you can't see here in these lines, unless you really squint, but I will tell you is the case, is that in this instance, direct cash aid actually helps a lot. It keeps people above hunger thresholds. Transportation hurts. And it hurts because the poor people still don't get any food, and instead the wealthier people that are already doing okay use the transportation to export their food to other markets where they can get a higher price. Okay? And so it's looking at these different interventions, both intended to help local food security and trying to understand how you'd have to plan properly for those. Okay, so just to end with the questions I started with, again, I don't even want to say have I convinced you, because I'm not trying to convince anyone here. But this is what we're trying to do, looking at these sectors, okay? Food, energy, and water across scale. Maybe they're useful for thinking about resource development. And when we think about the utility, that's where, again, I think this is very scale dependent. So I suppose the only conclusion I'd have is that in answering these questions, you need to think about what scale you're thinking about and be cognizant of cross-scale interactions, because that's where a lot of the unintended consequences happen when you come up with a nice, neat solution that works at one scale. And that's all I've got, so I'll take questions. Yeah?
Thank you very much for the very interesting talk. You made a very good point that when we add one more component, we're adding more stakeholders, that we're going to see more winners and losers. It also means that that will be a more diverse interest group that we're going to observe. I'm just curious, given that once we consider nexus, we're actually creating more diverse interest groups, what should we tell policymakers? Because we're actually making this policymaking even more complicated than before when they only consider one issue.
That's right. Yeah, so, I mean, I think that the first lesson from this that is learned from many other, integrated water management already showed this, right? But is the problem of stovepipes. okay? So in some ways it's more complicated, and it's certainly bureaucratically more complicated because you have to map out all these stakeholders and bring them together, and a lot of people have worked on that. Once you get together, though, the advantage here, I think that the carrot is the degrees of freedom that it brings to the problem, right? And so if you start off with water alone, in the basin scale case, right, you're fighting over 1 billion cubic meters of water just because that's all you have to fight over, right? If you bring multiple sectors together, then suddenly more opportunities arise, and I think that that's the motivation for this. That doesn't directly answer your question because you still have to do that hard work of getting these stakeholders together, identifying them, bringing them together. But I think that that's a challenge that increasingly people are willing to take on because of the potential benefit.
Yeah, it seems like a lot of what's going to happen in the region as a result of this dam is what happens in the Sudan with respect to irrigation and agriculture. And you said that currently Sudanese agriculture is very inefficient, became more efficient. Could you describe a little bit more what you mean by its agriculture is inefficient and what would it have to do to change that?
Yeah, so the easy part of the answer is engineering, okay? So right now, because of the amount of sediment that comes in, they actually spend a lot of money on dredging every year, dredging the irrigation canals, okay? That will no longer be necessary, which maybe frees up some resources to fix the irrigation infrastructure, all right, which is decrepit and inefficiently operated, okay? So that's a water management issue. Now, where this gets further from my expertise, but what I'm told is that there's also a big question of kind of socioeconomic, social and economic dynamics about who owns the land in these big irrigation developments, whether it is really their primary source of income or not, okay, and also how the reliability or lack of reliability in irrigation water distribution has impacted their investments in the land. So the net total of it is that that you're not getting a lot of production, okay? How you modernize that, I think, is a question that I don't know the answer to, but that there are plenty of options, right? There's an engineering answer, and then there's a question of where does the investment come from, and I think that those things could be taken on. I don't know why it hasn't happened yet, okay? That gets into, I think, more of Sudanese resource dynamics than I'm really equipped to discuss. Yeah.
So my question is also goes back to this policy trade-off. So to what extent are these countries in this area, so think of, for example, Ethiopia, are they already thinking of these issues in terms of water, food, energy, trying to make these multidimensional trade-offs to solve these problems? Or it is something that would have to happen in the future?
In the case of Ethiopia, I think yes. I think that they are. They a few years ago consolidated their ministries. What used to be the water ministry, and then they combined once, and they combined twice, and now it's a ministry of water, energy, and irrigation. Maui, yeah, water, irrigation, energy. And so they're already trying to break those stovepipes. Okay, and so I think there's that recognition. They've also had a lot of development plans that have kind of pointed at this. In that sense, calling it the food, energy, water nexus maybe just helps make some of these connections explicit and pulls it together, but I think that it's already very much on their radar. I don't know enough about the other countries. I mean, in Egypt, certainly those dynamics have been played for a very long time, so I'm sure they're thinking in those terms. Whether they have development plans like Ethiopia does that really call that out, I'm not sure. Yeah.
So, in terms of the use of irrigation and also hydropower, it seems to me like contradictory use. So, which do you think is more equitable usage of the water, or like what should we do? Like, on one hand, we need the water to irrigate, on the other hand, we need to develop.
Yeah. So I don't know the answer to that, right? And some of this comes, here's one comment that I will make about this, right? That a lot of this depends on your labor force, right? So in so much as irrigation helps the productivity of your agricultural sector, it's very tempting to do that when a lot of your country is involved in agricultural labor, right? As that labor force moves out of the agricultural sector, then perhaps energy for more industrially oriented development becomes a higher priority to the government. You still need to produce food, right? So like, I mean, irrigation is never going to go away. But I think maybe in terms of the balance, for a decision maker, that ends up being a large factor. The good news, all right, on the Nile, and now, so people have very strong feelings about dams, okay, right, whether you should build them or not. It's pretty hard to argue that Ethiopia shouldn't be building this dam. I mean, it's it's transformative, right? And so the good news here is that you are like, I mean, despite all the tensions, you're like revolutionizing both electricity and, if we cooperate properly on this, the potential for better food production downstream, okay? So it really could be, right, a benefit to both. So we aren't necessarily in a world where the trade-off, at least at basin scale, is coming at us, right? It's not like a situation like, uh-oh, what are we going to do? It's like, no, actually, there are a lot of opportunities here. So in this one instance, I think that the trade-offs are manageable because the opportunity is larger than the trade-off. That's debatable, but that's my perspective on it right now. And I think it's different from some other places where you might be dealing with the same question you're asking, and there actually is kind of like a real hard stop where countries, either within a country or between countries, have to make a very hard decision. Yeah.
So is energy cost in the area a large hurdle for industrialization?
I'd say reliability. Yeah, is my understanding. Again, I'm not an expert on the industrial sector, but you need more reliable electricity, just more electricity. The cost itself, the question is what industry you're in, right? I mean, I think for most industries, unless you're smelting aluminum or something, your energy costs are appreciable, but might not be the biggest percentage compared to other factors, at least for the industries that are active right now. Yeah.
Another question. What do you think are the key challenges to achieve integrated planning for these three issues, water, energy, and food, for the three scales you talked about just now, respectively?
The key, sorry, I missed the
Key
first one.
challenges.
Key challenges.
Yes.
Right. So again, it's scale dependent,
Yes.
right? So I'll refer to convention on this one because I think the conventional view is probably right. It's like if you're talking about basin scale, water is a means. So I'm not going to talk about like water as water, even though that's what the treaty is written about. Energy, I think, is such an opportunity area. All right, that there's going to be so much more energy coming onto the system that's mostly a positive, and that's true for the specific plan of the GERD, but also in general. And so I think that I would have to say that the challenge is food, okay, and not necessarily food as in like who's going hungry, because that becomes a global issue, right? We're an integrated economy right now, but maybe if we want to think, for example, for the downstream countries, particularly Egypt, I think their big concern here is that they still have a large rural workforce, right? Agriculture is a declining percentage of their economy, but is still a large percentage of their workforce, and they want to make sure that production, those people can stay on the land and be productive. And so figuring out a way to do that, which it doesn't have nothing to do with the GERD, but that's just a convenient target, right? I mean, they've got problems of salinity, they've got problems of subsidence of the delta, they've got problems of inefficiency, they've got that specter that I just raised of Sudan suddenly taking all their water, right? But all of those factors need to be taken on. So that's really the challenge, is getting away from thinking about this as just a Nile. It's about the Nile, but it's not necessarily about development on the Nile. So that's the basin scale. I would say, for speaking to Ethiopia, local scale food, energy, water, and the part of the country I'm in, it's hard to say. So Ethiopia, of course, people know that there are food security issues. This part of the country actually does reasonably well. Okay, it's not, what people would refer to as hungry Ethiopia. I hesitate to say that a little bit because we've gone out with public health experts, and if you actually look at stunting rates and wasting rates in children, it's like people are going hungry. So we don't call it hungry Ethiopia because it's not like a famine, but there's a food security issue. But nevertheless, I think that energy is a big, big deal here. And this is something that the government's working on, right? Which is, they're suddenly going to have this surfeit of energy, right? They're going to be generating tons and tons of electricity, but there's no grid to get that out to the rural areas. it doesn't look like they're, and where the current distribution of population, I mean, people live on homesteads out in the middle of, like, it take a very long time to get the grid there. And so trying to figure out, there's this idea of villagization in Ethiopia, saying, oh, wouldn't it be better if people kind of moved into areas where we could get electricity to them? So that's one possibility. The other possibility is off-grid generation, right? And so that, when I think about the questions that we don't know the answers to, I'm more on the energy side locally, and maybe the food production, rural labor force base and scale. But that's just one opinion. Yeah.
Decades ago, there was a lot of interest in trying to increase the flow of the White Nile into the north.
Yes.
And is that completely dead now, or is that still being discussed in some circles?
It's being discussed. If you can find a contractor who wants to go work in South Sudan right now. I mean, it's so this is the Jonglei Canal plan, okay? And so the idea that the White Nile is this buffered, isolated system that has no impact on Egypt, while the Blue Nile and Eastern Nile has a direct impact on Egypt, that dichotomy only works as long as the Sud is there and not bypassed. In the 1970s and 80s, there was an effort that almost succeeded to dig a canal that bypasses the Sud, and then you have the Jonglei Canal bringing water downstream. Egypt is very interested in this. They can continue to be interested in that. I think the first trip of the Morsi government, it's hard to keep track these days, but the first trip of the Morsi government was to go to South Sudan and start talking about Jonglei. Obviously, both of those countries have had political change since. So that discussion is open, and we've been looking into what that would mean, both for the flows as well as for the Sud itself. So it falls in the kind of in-between area, like it's not science fiction. It almost happened. It could happen again. But what you'd require in terms of political stability, those conditions aren't ripe right now. And I would be worried, if I were, in a hypothetical sense, if I were a responsible leader of South Sudan, right, I'd be really worried about changing the seasonal flooding pattern of the Sud. It's a big, and so, once establishing peace in the country, my first act would not be to entirely change the hydrologic system that supports people's livelihoods. So I don't see it happening, but I could be proven wrong any day. Yeah.
Do you have that graph elaborating like the mechanism between like household welfare and the energy hydropower building infrastructure, something like that? Could you please elaborate if we want to know like the correlation or the effects of the energy infrastructure in that area bring to like household, like the poverty reduction?
Yeah, so we talk about this a lot, and so I don't have an answer, but we talk about this a lot, and the question is, and Johannes, I'm sure you think about this a lot, like, what do people do with electricity, right? What do they do with energy? Great, it's nice to have it as a goal, empower Africa, get everyone electricity, then what happens? And so, there's the ones that come up again and again in my conversations with people in these villages. One is post-harvest processing and storage of food, okay? Refrigeration. Now, these are energy-intensive processes, right? So it's not obvious you're going to get there immediately. Like, it's harder than a light bulb. But refrigeration's big. Being able to thresh, dry, and process your agricultural output is big. Then the next thing is some kind of mechanized tillage, which is tricky, right? Because tractors don't necessarily work well in these places. So you're talking about smaller devices that they're not going to be electric powered. Like that's more of probably a gasoline issue. But if you had energy, then people would try to change that, which ends up having a big impact because then you don't have to keep as many livestock. Okay, and so that's a huge impact. Then also if you could at some point, and we were talking about this, I was talking about this with Johannes earlier, the challenge of fuel wood for cooking, right, which is kind of one of those grand challenges that never goes away. It requires a lot of energy, and there are cultural preferences at play. Nevertheless, if you somehow release that pressure that's causing deforestation on the mountaintops and eucalyptus plantations in the fertile Midlands, you push back on the poverty trap of land degradation and low investment in agriculture. And so I think there's a lot of opportunities there, and that's all thinking very conventionally about the agricultural sector, right? Then there's like bring electricity to the internet, and who knows what happens, right? And I can't predict, but at least there's some direct impacts.
How much they have to grow the grid to get to that point?
Depends on that point. I don't think so. Right, good question. If we're actually talking about getting the grid to households, like out in the middle of nowhere, like every time I've had this conversation with people, it kind of ends with a like, it's not going to happen, and that's not true. I think there are beneficial studies, and so I should know that number, and I don't. But that if you're really talking about getting electricity to everyone where they are right now, we're probably talking about off-grid. And this is not just Ethiopia, right? This is the big discussion in Africa right now, right? Or it's one of the big discussions, right? Is what's the best thing? If any optimization modeler can tell you it's better to be on the grid, right? It's more efficient, it scales. But yet, if you're not going to get the grid to these places because of investment or logistical challenges, then what point do you say that, oh no, it's still worth doing this off-grid stuff? And also the technologies are changing all the time. So when I picture this happening, I don't picture a grid coming to every household. But Ethiopia could have plans I don't know about. Johannes, you know more about this stuff than I do. I don't know exactly what the opportunities are and trade-offs. All right.
All right, if there are no more questions, let's thank Ben again for a great talk.
Thanks, guys.
All right, that was good.